Dear students, I am Ramesh. Today we are going to discuss on the topic inductive effect in organic chemistry. Before moving to the main topic, we must know the concept of covalent bond. What is a covalent bond? A covalent bond is formed by the mutual sharing of electrons between two adjacent atoms. Let us consider this example. Here, the covalent bond between two carbon atoms is observed. Covalent bond between carbon and chlorine is there. When we consider this covalent bond, this chlorine possesses high electronegativity. As a result of that, the shared pair of electrons will move towards chlorine atom. This resulted a partial negative charge on the chlorine atom and partial positive charge on the carbon atom. So this is the first carbon, this is the second carbon, this is the third carbon, and this one is the fourth carbon. So the movement of shared pair of electrons towards the chlorine atom creates a partial positive charge on the first carbon and a partial negative charge on the chlorine atom. This effect is extended throughout the chain of this carbon chain. This effect will extend throughout the chain. As a result of that, the second carbon also experiences a part of the pulling power of chlorine atom. This creates a partial positive charge but less than the first carbon. And the third carbon also experiences a partial positive charge very less than that of the first carbon. And the fourth carbon also experiences very less positive charge when compared to the first carbon. We can consider this as negligible. So, the effect of movement of shared pair of electrons towards the chlorine atom is extended throughout the chain, but the effect will decreases when the distance increases. This effect is known as inductive effect, which is a permanent effect. Why I say permanent effect? As long as this molecule exists, this effect also exists. Now we can define inductive effect. It is a permanent effect due to the movement or shifting of shared pair of electrons towards more electronegative atom, and this effect extends throughout the chain, but the intensity of effect decreases with the distance. Let me repeat, it is a permanent effect due to the movement or shifting of shared pair of electrons towards electronegative atom, and this effect extended throughout the chain but decreases with the distances. As a result of this movement of electrons towards the electronegative chlorine atom, the chlorine atom will get a negative charge and this carbon group will get a positive charge. So we can say that when the electrons, the group from which electrons are moving, or if the electron is moving away from the group, is known as plus I group. So we can call this carbon group as a plus I group or electron releasing group. And towards a group, the electrons are moving towards a group, which is known as minus I group or electron withdrawing group. So inductive effect can be classified into two, plus I groups and minus I groups. Now we move on to the examples of plus I and minus I groups. Inductive effect can be classified as plus I effect and minus I effect. When we consider the plus I effect, all alkyl groups are showing plus I effect. So let's consider this example. This is a tertiary alkyl group. This is a secondary alkyl group. This is a primary alkyl group. The last one is a methyl group. When the central carbon is bonded with three other carbon atoms or alkyl group is known as tertiary. So the plus effect of alkyl group will depend on two factors. One is the number of carbon atoms. When the number of carbon atoms in the alkyl group is increases, plus effect of that particular group is also increases. Let me write it out. Number of carbon atoms increases, plus the effect also increases. In addition to that, the degree of central carbon atom. When the degree of central carbon atom is high, plus the effect of that particular carbon atom or group is also high. So the order is as follows. Tertiary alkyl group experiences very high plus the effect than secondary, which in turn greater than primary. So in this case, in this example, we can return the order as tertiary group experiences very high plus the effect than secondary and primary, and very less is belongs to methyl group. So this is the plus effect of alkyl group. Now we move on to minus effect. All functional groups are showing minus effect. The order is as follows. Nitro group experiences very high minus effect than cyano, and carboxylic acid group, X is halogen, and methoxy group, alcohol group, and phenyl group. When this X, fluorine process very high minus effect than chlorine, which in turn greater than bromine and iodine. This is because fluorine possesses very high electronegativity. The minus effect of a group will also depends on the hybridization, where there is a very high S character. When the S character is more, minus effect also very high. So sp hybridization possesses very high minus effect than sp2 than sp3. In sp hybridization, S character is 50%, sp2 it is 33%, sp3 it is 25%. So the minus effect is shown by all functional group, and in addition to that, hybridization of a particular group also has effect on these minus A groups. When the S character is more, minus effect is also very high. In all these cases, there is one exception is there. As you all know that a metal atom is electropositive in nature. When a metal atom is present along with halogen, let's consider this example. This is one of the famous reagent in organic chemistry known as Grignard reagent. So when a metal atom, here it is magnesium, is present along with halogen. As you all know that halogen showing minus effect. But when a metal is present along with the halogen, the shared pair of electrons, metal will donate the electrons to alkyl group. As a result of that, alkyl group will become minus I, and this halogen group, the metal group, will behave like a plus I. You should remember this exception because as we already discussed that alkyl groups are showing plus I effect, but in this particular case, when a metal is present with the halogen, alkyl group will behave like minus I, and the halogen group will become plus I. Okay, let's move on to the application part of inductive effect. Understanding the concept of inductive effect is very important to predict the feasibility of organic chemical reactions. We are going to discuss 4 applications here. The first one is the stability of carbocation. What is a carbocation? It's an intermediate in an organic chemical reaction. A carbon carrying positive charge. Before applying the inductive effect on the stability of carbocation, we must understand one concept. The stability of an intermediate like carbocation increases with a decrease in the charge carried by the carbon atom. Let's consider this example. This is a tertiary carbocation. The central carbon is carrying the positive charge which is bonded to 3 other carbon atoms. And here the central carbon is bonded to 2 other carbon atoms. Here only 1, and this is methyl carbocation. What is the effect of alkyl group? Alkyl group is having plus I effect. So it will release electrons towards the central carbon atom. As a result, what we just apply this concept. The stability increases with the decrease in charge. So when electrons are released towards the central carbon atom, the positive charge decreases. It decreases. Hence, the carbocation, the tertiary carbocation is very high stable. We already discussed in the plus I group section that when the number of carbon atoms increases, plus I effect also increases. So tertiary carbocation is having high stable than secondary, which in turn greater than primary, and then methyl carbocation. So order of stability of carbocation is as follows. Tertiary is greater than secondary greater than primary. So what is the effect of minus A group on this carbocation? Suppose a chlorine atom is attached to a carbocation. Okay, a chlorine atom is attached to a carbocation. This chlorine is having minus effect. So it will withdraw electrons from the central carbocation. This will intensify the positive charge. The electrons will again moving away from the carbon atom. This will intensify the positive charge. So charge get increased, stability get down, stability decreased. So let's conclude. Plus A effect increases the stability of carbocation, whereas minus A effect decreases the stability of carbocation. Now we move on to the second application, the stability, how inductive effect can be used to determine the stability of carbanion. Okay, the stability of carbanion. How we can apply inductive effect on determining the stability of carbanion? Carbanion is nothing but a carbon carrying negative charge, just like a carbocation. It is a carbon carrying positive charge, here a carbon carrying negative charge. So, just remember this concept. The stability of a carbanion increases with a decrease in the charge carried by central carbon atom. Now apply plus A effect. The plus A effect of alkyl group. Alkyl group will release electrons towards the central carbon carrying negative charge. This is a tertiary carbanion. So when the number of carbon atoms increases, plus A effect also increases. Here the negative charge get intensified. As a result, stability get decreased. Let's consider the secondary carbanion. Here two carbon atoms are there, two alkyl groups are there. The plus A effect of two alkyl group intensify the negative charge on the central carbon atom, but which is less compared to tertiary. So the stability of secondary carbanion is greater than tertiary. So primary carbanion is in turn greater in stability than secondary, and methyl carbanion is very high stable because the plus A effect is negligible in the case of methyl carbanion. So the order of stability in the case of carbanion is as follow: less than tertiary, less than secondary, less than primary, less than methyl carbanion. Okay, so plus A effect decreases the stability of carbanion. Let's consider the same example we discussed earlier. A chlorine bonded to a carbanion. What is the effect of chlorine atom? Chlorine is having minus A effect. So it will withdraw electrons from the central carbon carrying minus negative charge. As a result, the negative charge decreased. So stability of carbanion will become increased. So stability of carbanion is increased when a minus A group is there. Minus A effect increases the stability, whereas plus A effect decreases the stability of carbanion. Let's move on to the third application of inductive effect. How we can use inductive effect to determine the acidity of carboxylic acid. What is acidity? It's nothing but it's a capacity or tendency of a group to release H plus ion. Let's consider this example. The acidity of a carboxylic acid, it depends on two factors. The first factor is the capacity of carboxylic acid to release this H plus, to release this hydrogen as H plus ion. That's the first factor. The second factor is that if it releases this H plus ion, the stability of carboxylate anion, the stability of this carboxylate anion is very important. If it is not stable, the acidity also decreases. So the stability of a anion will increases with a decrease in the charge carried by the carboxylate anion. We have already discussed in the case of carbocation and carbanion, stability increases with a decrease in the charge. So, the second factor is the stability of carboxylate anion. Now we move on to what effect inductive plus I and minus I group can influence on this acidity. Let's consider the first example. Here, in the case of acetic acid, an alkyl group, CH3 group, which is plus I effect, which is bonded to carboxyl acid group. The plus I effect of CH3 group will releases electrons towards the carboxylate group. As a result, the tendency to release H plus ion will decreases. And the plus I effect of alkyl group will intensify the negative charge on the carboxylate anion, thereby decreasing the stability of carboxylate anion, which in turn decreases the acidity. So, plus I effect decreases the acidity. How? By decreasing the stability of carboxylate anion and releasing electrons to the carboxylic group by decreasing the capacity to release H plus ion. When we consider a chloroacetic acid, that's the second example. Here, chlorine is having electron withdrawing effect. So, it will withdraw electrons from the carboxylic acid group. As a result of that, the H plus ion, the release of H plus ion become very easy. So, it will release H plus ion. It will release H plus ion very easily. That is the first factor. When, in the case of carboxylate anion, chlorine, the minus I effect of chlorine will withdraw electrons from this carboxylate anion, thereby decreasing the negative charge, thereby increasing the stability of carboxylate anion. Minus I effect stabilizes the carboxylate anion, thereby increasing the acidity. So, we can conclude that presence of a plus I group decreases the acidity of carboxylic acid due to it intensify the negative charge on the carboxylate anion. Whereas minus I effect, the presence of a minus I group increases the acidity. How? It stabilizes the carboxylate anion. Okay, let's move on to the fourth application, that is the acidity of alcohol. Just like what we have explained in the case of acidity of carboxylic acid, we can apply the same concept here also. The acidity of alcohol depends on two factors. First one, the capacity of alcohol to release this pH plus. That is the first factor. Second factor is the stability of alkoxide anion. This is the alkoxide anion. This is stability of alkoxide anion. When stability increases with a decrease in the charge carried by the alkoxide anion. Let's consider the example. We are going to apply plus I effect. This is a methanol. And the alkyl group is having plus I effect, which releases electrons to the OH group, which decreases the capacity to release H plus ion. In addition, if the H plus ion is moved, what will going to happen? The alkyl group releases electrons to the negatively charged alkoxide ion, which intensify the negative charge, thereby decreasing the stability of alkoxide ion. So, we can conclude plus I effect decreases the stability of alkoxide anion, thereby decreasing the acidity. Okay, now we move on to the minus effect. This chlorine atom is having minus effect. It withdraw electrons from the OH part. As a result, the release of H plus ion become very easy. If it is released, in the case of alkoxide anion, the chlorine will withdraw electrons from the alkoxide group, which decreases the charge carried by alkoxide group, thereby increasing the stability. So we can conclude that minus A effect increases the acidity by decreasing the charge carried by alkoxide anion. So plus A effect decreases the acidity of alcohol, minus A effect increases the acidity of alcohol. So we have completed the section. Thank you very much.